Hello everyone. Today I have the last 5 questions of NEET 2016 series CRY. The questions are from 41 to 45. The 41 question. A piece of ice falls from a piece of ice falls from a height h so that it melts completely. So that it melts completely. Only 1/4 of it produced is absorbed. By ice. And all energy of the ice and of energy of ice gets converted into heat. During its fall. The value of H is now options. First option is this is 68 kilometer. Second option is 34 kilometer. Third option is 544 kilometer. And fourth option is 136 kilometer. And here given the latent heat of ice equal to 3.4 into 10 raised to power 5 joule per kg, and G equal to 10 this is given to your Newton per kg. This is the given question. Now you read this question and you will find that this is the conversion of work into the heat. And we know that for every unit of work, the heat is produced. So this W is equal to H. Solution. Heat produced H equal to W. Since this heat is given in a joule, so we take this H equal to W. If this were being given in the calories, then H equal to W upon J. This we have to take the relation. But J will not be used here because all the units are given in joules. H, and this is given that only 1/4 quarter of the heat is absorbed by the ice. So what this W will be 1/4 of its total energy. So this is your W by 4. H, now this is your ml, this is mgh upon 4. Now this m and m will cancel. We have to find this h. Therefore h equal to 4l upon g. Now this is given to us, that is now 4, l is so much. This is given 3.4 into 10 raised to the power 5 upon g is given to you now this 10. So this remove this 0, point from here, this is now 100, then this will be your 10 raised to the power 3, and this is now your 16 and 12 and 30. 136 into 10 raised to the power 3. So much meter. So this is equal to 136 kilometer. So height from which the ice block for freely is 136 kilometer. So our right answer is fourth one. This is the fourth answer. This is now right option, the fourth one. This is question number 41. Now question number 42. A square loop ABCD. A square loop ABCD carrying a current I. Carrying a current I is placed near and coplanar with long straight conductor. Long straight conductor XY carrying current I. The net force on the loop. The net force on the loop will be now the options. First option is mu naught IIL upon 2 pi. Second option is 2 mu naught I upon 2 pi. And third option is mu naught I upon 2 pi. And fourth option is 2 mu naught I L upon 3 pi. So here we have a square loop ABCD carrying the current I. It is placed near and coplanar with the long straight conductor XY. What is here that the figure is not given, but this must be given to be here because we don't know that what is the distance of this straight conductor. So it becomes a very unclear question. So from ourselves, this is now your conductor A, B, C, D. This is a long conductor carrying the current I. This carries the current I like this, in this way. And the L is also not given here, so this you take now this L length, and this is L by 2 is so much. So now you can see the sides A, B, C, D are given to here, and this AB, here the current in this one and the current in this conductor are in the same direction, so they will attract. So this will apply the force of attraction F1. This is the current flowing like this, so by taking the left hand rule, the force will come out to be in this direction. This is now F2. And this force will, this is current I and this is current I are in opposite direction, so they will repel to each other. So this will be the force F3, and similar forces will be here. This is now your F3, F4. So what we have? Another 4 forces are acting on this loop. So the force net force F is equal to F1 plus F2 plus F3 plus F4. The force F2 and F4 are, these are the collinear forces. Force F2 and F4 are collinear forces. So F2 is equal to minus F4, or F2 plus F4, this is equal to 0. So F2 and F4, the sum of these two is equal to 0. So only remaining force will be F1 plus F3. Hence therefore net force F is equal to your plus F3. Now you can see that F1 and F3 both are in opposite direction. So there will be the difference of these two forces. So now we have to calculate the force F1. Force F1 is equal to mu naught upon 4 pi into 2. Our formula is mu naught upon 4 pi into 2 I1 I2 upon R into L, the length of the side or length of the conductor. So here this is not given to here. Mu naught I into I into L. L the length of this side. So this is now your L upon the distance from this one is L by 2. So this is L by 2. And now you can see from here that this F1 is equal to your mu naught upon 4 pi into this is now 4 I into L upon L. So this L will cancel and 4 will also cancel. 4 will cancel. So we are left with mu naught I into I upon pi. So much. And now force F3 is equal to mu naught upon 4 pi into 2 I into side L upon this distance. The distance between this conductor XY, this is now given to XY and CD. Direction is the side CD. This is L plus L by 2, so 3L by 2. Total is 3L by 2. 3L by 2. So much. So what will be this? F3 equal to, this is your mu naught upon 4 pi into 4 L upon 3L. So now we will cancel this L to L and this 4 to 4. So we are left with mu naught I into I upon 3. So much. So now we find the net force. Hence F equal to. Now this will be in the both are in opposite direction. So we will have this F1 minus F3. So F1 mu naught I into I upon pi minus mu naught I into I upon 3. So this will come out to be, this is now 3, so 2 by 3. 2 by 3 mu naught I into I upon pi. This pi is also here. Pi. So much force will act on this loop by this wire or the conductor XY. So we have the right answer is to be this one. 2 by 3 mu naught I upon pi. This is not correct answer. So our right choice is fourth. So this is what the direct application of the formula when the two conductors are carrying the current and they are parallel to each other at a distance d apart. So the formula is mu naught upon 4 pi into 2 I1 I2 upon R into L, the length of the conductor. This is question number 42. Now question number 43. 43. ये यूनिफॉर्म रोप of length L and mass M and mass M1 hangs vertically from a rigid support. A block of mass M2 is attached to free end of the rope. A transverse pulse of wavelength lambda 1 is produced at the lowest end of the rope. The wavelength of the pulse when it reaches at the top is lambda 2. The ratio lambda 1 upon lambda 2 is now the options. Now the option is, first is your square root m1 plus m2 upon m1. Second is square root of m1 upon m2. Third, square root m1 plus m2 upon m1. Now this is m2. And fourth is square root m2 upon m1. This is given to us. Here we are given a rope. This is the block. Its mass is m2 and mass of rope is equal to m2. This is m1. This is m. When a transverse pulse is given to this rope at the lowest end, then this will move towards the support. So we know that when the pulse is given to this one, then a transverse wave is produced. So just we move it like this. So this goes upward. So what here? That the velocity of pulse v equal to square root of t upon m. T the tension in the string. T equal to tension. M equal to mass per unit length of rope. So this mass per unit length of the rope will remain constant, and here the tension will vary because the rope is not ideal, but this is given the mass m1. So this tension T, this is equal to mg. So now from here we can see that this formula V equal to n lambda. Transverse wave is produced, then it will have the velocity. So the velocity is also given by this formula, this is also given by this one. So we will have this. So this n lambda equal to square root of t upon n. So it gives you that lambda is proportional to square root of this now t. Now at the lowest end, what will happen? At the lowest end, the tension in this string is due to this mass m2. This is suppose point A and this is now suppose point B. So at lowest end B of the rope, T equal to mg. The tension in the string is only, is m2, only because of this mass m2. So this lambda 1 proportional to square root, g is constant, so we take it to be now m2. G equal to constant. When this pulse reaches at this point A, highest point A, then the tension in the string will be because of this mass m1 and that mass of m2. At top point A of the rope, now this T is equal to m1 plus m2 into g. This is not so much. So now the wavelength, so lambda 2 is proportional to what? Square root of m1 plus m2. Now what is given? We have to find the ratio of this lambda 1 to lambda 2. Therefore, lambda 1 upon lambda 2. Lambda 1 is the square root of m2 and this is now square root of m1 plus m2. So what we have? This lambda 1 upon lambda 2 equal to square root of m2 upon m1 plus m2. Now you can see that there is no such option in this one. Okay, all the options are not matching with this one. None of the option is matching with this one. It means that the lambda 1 and lambda 2 is not to be found out. So what is wrong in the question? Wrong in the question is that it must be lambda 2 ratio lambda 1. So we have to find the ratio lambda 2 ratio lambda 1. Then this will be now so much relationship. Lambda 2 upon lambda 1 equal to square root of m1 plus m2 upon m. So our right choice is this one, third one. So what must be there? The question must have the language that the ratio, what is the ratio lambda 2 upon lambda 1, not lambda 1 upon lambda 2. Right answer is third. This is now 43rd question and now 44th question. 44th question. A black body is at temperature of 5760 K. The energy of radiation emitted by the body at wavelength 250 nanometer is U1. At wavelength 500 nanometer is U2, and that at 1000 nanometer is U3. Wind displacement constant means displacement constant B equal to 2.88 into 10 raised to the power 6 nanometer Kelvin. Which of the following is correct? Which of the following is correct? Now the option is u2 greater than u1. Second is u1 is equal to 0. Third is u3 equal to 0. And fourth is u1 greater than u2. This is given to us. So now solution to this question. Now by Stephen's law, E proportional t to the power 4. So this E equal to sigma t to the power 4. By B's displacement law, lambda into t equal to b. So this t equal to b upon lambda. So now you can have this E equal to, therefore this E equal to sigma b upon lambda raised to power 4. So this E equal to sigma b4 upon lambda to the power 4. So now you can see that this E is proportional to 1 upon lambda to the power 4. It means that whenever we are given the wavelength at a certain temperature, then there will be the emission of heat radiation. So that will follow this relation. And we know that you are given this, the wavelengths 250 nanometer, 500 nanometer, 1000 nanometer. So as the wavelength increases, E will decrease. It means that E will be maximum for the minimum wavelength. And the minimum wavelength given here is this one, this U1. Or lambda 1 equal to 250 nanometer, E equal to U1, lambda 2 equal to 500 nanometer, E is equal to U2, lambda 3 equal to 1000 nanometer, E is equal to U3. So from this relation, it readily follows that this U1 is greater than U2, greater than U3. None of them will be 0. So the option, this second and third are automatically wrong. Now we are having the first and fourth option. So now first and fourth, this U1 is greater than U2. So this is now U2 greater than U1, here this U1 greater than U2. So our right choice to this question is fourth. Answer. This is now fourth one. U1 is greater than U2. This is the minimum wavelength from this given the wavelengths. So this U1 will be higher value and U3 will be the lowest value. तो हम इससे देखते हैं कि भाई U1 का मान जो होगा वो U2 से ज्यादा होगा। दिस इज क्वेश्चन नंबर 44। नाउ क्वेश्चन नंबर 45, द लास्ट क्वेश्चन ऑफ दिस सीरीज। Out of the following options, which one can be used to produce a propagating electromagnetic wave, Now the option is an accelerating charge, second is a charge moving at constant velocity, constant velocity, and third, a stationary charge, and fourth option is a charge-less particle. So if you read this question, then this is the characteristic, or I have told you in the definition of the charge also, that charge is the physical quantity that produces the electric field, magnetic field and electromagnetic radiation. The electric field is produced when the charge is at rest, and magnetic field is produced when the charge is moving with the constant velocity, and also it produces the electric field. So the charge, when this is accelerated, then it produces electric field, magnetic field and the electromagnetic radiations, all the three quantities. So when the charge is accelerated, then this will produce the electromagnetic wave. So our right answer is first one. So this is the your NEET 2016 questions, and I think that I have solved the 5-year NEET question papers, this 2016, 17, 18, 19 and 20. 21 will be held this year. So now 5 more this question papers I have solved, and if you study all these question papers, you will find so many questions which are common and asked in the NEET exam. So you study the paper carefully and then find the solution of the questions. When the question is very tedious, then you leave it and go on the next question and then find the answer. So what we have, that the language of the questions is sometimes twisted one, sometimes is direct language. तो उसमें क्या होता है, डायरेक्ट लैंग्वेज होती है तो स्टूडेंट कर लेता है उसको, अगर लैंग्वेज ट्विस्ट कर दी गई तो फिर उसके बस की बात नहीं होती है। तो अब क्या करना है आपको कि इस तरह के क्वेश्चंस को सॉल्व करने के लिए थोड़ा सा टाइम चाहिए। तो क्वेश्चंस को आप सबसे पहले क्वेश्चन की लैंग्वेज समझें अच्छी तरीके से, एंड आफ्टर दैट यू ट्राई टू solve the question by applying the proper formula and then calculate and find the right answer. Thank you.